Lane. This is Blair. The standards are forces, and I'm going to take a few seconds so that you can read the question. Here's the picture. Okay, and here's my free body diagram. Okay, they're all vectors because they all have magnitudes and they all have directions. Okay, so the N is the normal force. It's always perpendicular to the surface. That's why it's at an angle. W is gravity, which is always straight down. Yes, they're supposed to be the same in magnitude. This is going to be the force being applied, moving in the positive x direction because the movers are pushing the safe up the incline, positive x direction. This is going to be friction. Yes, it's going in the negative x direction because force is opposing as you're applying this force. It's opposing the force. And yes, the force is going to have a larger magnitude than the friction because you're going to have to exert a greater force to exert the force of friction initially. So anyway, they both, these components, okay, so like friction and force, they both have an x component. N only has a y component. Now gravity has a x and y component, and this is because the x and y axis is, I guess you can say tilted, okay? And I took it to mean tilted, okay? And this is because of the normal force. So this is the dotted line, okay? This is the dotted line. It's, you know, moving in the negative y direction and negative x direction. This is going to be the hypotenuse, which represents gravity, which is just negative mg because, you know, gravity is moving in the negative y direction. Okay, and this is going to be the angle. So this right here, the x, is negative mg sine because, again, it's going in the negative x direction. And it's sine because it's opposite this angle. Y is also negative, but it's cosine because it is adjacent to this angle, and negative because it's going in the negative y direction. So that's how I broke down the W. Okay, and that's how I broke down W. Now, this, okay, this is going to be the equation that I'm using. So we don't know what the force is. That's what we're trying to find out. Okay, friction, I'm going to do that in a little while. Okay, so normal force. The x component of the normal force, there is none. It's 0. Okay, I just said what the x component of gravity was, and it's negative mg sine. Okay, we figured that out. Okay, now friction. Okay, so for friction, okay, and we're dealing, A wants static, well, A is static friction because it's asking, you know, how hard do they have to push so that the force can overcome the friction? Well, that's static, okay, because nothing is moving at this point. Okay, so this is the equation, and to get, okay, and to really make sense of this, what we're going to do is now, and these are all the x components, so now we're going to try and find the y components, because this will help, okay? Well, again, so it's going to be n minus mg cosine theta, you know, and this is just the y component of gravity, which is negative mg cosine right here, okay? And you set them equal to 0, you move them over on the other side, this is what you get. So that's what n equals. So now we know how to deal with friction. Okay, so now going over all of this, okay, So Fa, we're going to subtract that from the coefficient of static friction multiplied, and this is the n. This is the n right here, okay? So that's what we're filling in for, okay? And it's negative because friction is moving in the negative x direction. Also subtracting from negative mg sine theta. Why? Because that is the negative x component of W, or gravity. Okay, and of course n is just 0. And we set it equal to 0. We move everything over. On the other side, we isolate the force, and this is what we get. Okay. Now, this is, the book modifies this even more. So we got 2 mg's multiplying cosine and sine. So you just put 1 mg. You open up the parentheses, and since the coefficient of static friction is only being multiplied to the cosine, that's why it's right here with cosine. And of course the cosine and sine are being added, so that's why we add. Plug that in and you get 3,300 newtons. You might get 3,321 newtons, but they round it to 3,300 newtons, and that's the first part. That's A. Now B is asking for kinetic friction. Okay, or I shouldn't say it's really asking for kinetic friction, but because they because they want what the magnitude of the force must the movers push at a constant speed, well, that's kinetic, because at this point they've got it moving. So now we switch to kinetic friction, and it is the same exact steps, the same exact formula, except for the coefficient of static friction. We use the coefficient of kinetic friction, and we get 2,900 newtons.